Week 7 Hands-on Clustering Project, Socio-Economic Segmentation. Welcome to your hands-on clustering project. This week we will use the Mall Customers dataset. You will learn how to explore, clean, and segment customers using clustering techniques. By the end, you will be able to find groups of similar shoppers, a skill data scientists use for better marketing, product design, and more. Let us get started. Running the cell now. First, let us keep the coding environment tidy. This code makes sure we do not see warning messages, which keeps things clear for learning. Import numpy as np. We set the random seed to 42 for reproducibility. Running the cell now. This code sets up a clean and controlled environment by suppressing warnings and fixing the random seed for reproducibility. Although there's no visible output, these steps ensure that your clustering results will be consistent each time you run the code and free from distracting warning messages. This foundation is essential for reliable exploration and segmentation in your Mall Customers dataset project. Data setup, Mall Customers dataset. We will load the Mall Customers dataset. This dataset contains info like customer ID, gender, age, annual income, $, spending score, 1 to 100. Let us see what the data looks like. Running the cell now. Let us bring in the dataset and peek at its shape and the first few rows. We import pandas. We load the Mall Customers dataset from a public GitHub gist. We print its shape and preview the first rows. Running the cell now. The output shows our dataset has 200 rows and 5 columns, confirming the size we're working with. The first 3 rows display key columns like customer ID, gender, age, annual income, and spending score, giving a quick snapshot of the types of customer data available for analysis. This initial exploration helps us understand the structure before diving deeper into insights. Step 1. Exploring the data. Let us quickly see what columns we have and get some summary stats. This helps us spot missing or odd values early. Running the cell now. Now let us get some general information about the dataset. This line prints the list of column names. Here we see the data types and if there are any missing values. This line shows basic statistics, like mean age and highest spending score. Running the cell now. Here, we first identify the dataset's columns, confirming they represent customer demographics and spending metrics. The info output tells us there are 200 complete entries with no missing values, crucial for reliable analysis. Finally, the summary statistics reveal the range and distribution of key numerical features like age, income, and spending score, helping us spot any unexpected values before moving forward. Step 2. Checking for missing values. Missing data can be a major problem in analysis. We will check if any values are missing. Running the cell now. Let us count missing values in each column. We count how many missing entries are in each column. If the number is 0, that is good. Running the cell now. This output shows the count of missing values in each column of the dataset, and as you can see, all columns have 0 missing values. This confirms that our data is complete, allowing us to proceed confidently with analysis without needing to handle any gaps. Customer ID is just an identifier, so it does not help us group people based on their features. We are preparing the dataset for clustering by removing customer ID. Now our data has only useful features for segmentation. Running the cell now. In this step, we drop the customer ID column because it does not aid clustering analysis. Although no output is shown, this prepares the dataset by removing irrelevant information, ensuring our focus remains on meaningful features when checking for missing values. Step 3. Visualizing age and income. Let us visualize the age and annual income columns. This helps us understand the distribution and spot outliers. Running the cell now. Let us see the spread of ages and annual incomes with histograms. We bring in matplotlib for plots. We make the figure bigger so both plots fit easily. This shows us how ages are spread among the customers. Now we see how many customers fall into each annual income range. Plots are displayed together for comparison. Running the cell now. The two histograms show the distribution of age and annual income for the dataset. Notice the shape of the age distribution, which may reveal common age groups or gaps, while the income distribution helps identify typical income ranges and any outliers. This visualization confirms the data's spread and highlights if further cleaning or segmentation is needed. Practice. What feature seems most spread out in these plots? Try changing the color to see how it feels. Gender is a useful demographic feature. Let us see how it is distributed. We want to know how many male and female shoppers we have. This gives us a count of each group in the dataset. Running the cell now. This output shows the count of male and female customers in the dataset, with 112 females and 88 males. While the focus of Step 3 is on visualizing age and annual income, checking gender distribution helps us understand the sample composition, ensuring our insights on age and income consider any gender-related differences or biases. Algorithms cannot use words directly, so we change female to 0 and a male to 1. We are encoding gender so that it is ready for clustering. This numerical form is easier for computers to use. Running the cell now. Here we convert the gender column to numeric values, a key preprocessing step before clustering. While this doesn't produce visible output, it ensures that algorithms can interpret gender data correctly as zeros and ones, allowing us to focus next on visualizing age and income distributions. This numeric encoding is essential for integrating categorical data into our analysis. Step 4. Feature scaling. Features with bigger values can impact clustering more. We will scale features so all have equal weight. Running the cell now. Let us use a scaler to standardize all the columns, making them comparable for clustering. We import a tool for scaling features. Here we create an object to do the scaling. This step transforms all features to standard units. We print out the first 3 rows so you can see the scaled result. Running the cell now. This output shows the first 3 rows of our dataset after applying standard scaler, where each feature is rescaled to have a mean of 0 and a standard deviation of 1. Notice how the values are now centered around 0 and vary similarly across columns, ensuring no single feature will dominate the clustering process due to scale differences. This step is essential for fair comparison and accurate clustering results. Step 5. K-means clustering. Now for the exciting part, clustering. K-means helps group similar customers. You choose the number of groups, called clusters. Let us try clustering into 3 groups. Running the cell now. We will apply a popular clustering method called K-means to our customer data. We import K-means from Sklearn. We ask for 3 clusters and lock the random seed for repeatability. This line fits the model and assigns customers to clusters. We print the first 10 predicted cluster labels. Each label means a different group. Running the cell now. The output shows the first 10 cluster labels assigned to customers after applying K-means with 3 clusters. Notice how customers are grouped into cluster 0 or 2 here, reflecting distinct patterns in their features. This confirms the code is successfully segmenting customers into meaningful groups for targeted analysis. It is a good idea to keep track of which cluster each customer is in. We add a new column to show each customer's predicted group. This is useful for analyzing or visualizing the results. Running the cell now. Here, the code adds the cluster labels to our original data frame, creating a new cluster column that assigns each customer to a specific group. This step is key because it allows us to easily analyze and compare customers within each cluster, setting us up to explore their distinct patterns or behaviors in the next steps. Let us see a couple of example customers from each cluster. We loop over each cluster label. Here, we print the first 2 customers from this cluster. This helps us compare shoppers in different groups. Running the cell now. Here, we're inspecting sample customers from each of the 3 clusters formed by k-means. Notice how each cluster groups customers with similar income and spending patterns. Cluster 0 has lower income and spending, Cluster 1 shows higher income but moderate to low spending, and Cluster 2 has low income but varied spending scores. This output confirms that clustering helps segment customers into meaningful groups for targeted analysis. Try for yourself, change the head 2 to head 5 to see more customers from each cluster. Step 6. Visualizing the clusters. A plot helps us see the customer segments in action. Let us plot clusters using annual income and spending score. Running the cell now. Let us draw a colorful scatter plot to see if clusters are distinct. We use colors to make clusters easy to spot. This makes the figure large enough to see details. We plot one cluster at a time by income and spending. Points get colored by their cluster label. Each color represents a group. The labels and axes make the plot easy to understand. The y-axis shows how much people spend. The plot gets a title for context. A legend explains which color means which group. Now we display our cluster chart. Running the cell now. This scatter plot visually separates customers into 3 distinct clusters based on their annual income and spending score, with each color representing a different segment. Notice how clusters group customers with similar spending behaviors and income levels, helping us easily identify patterns for targeted marketing strategies. This visualization confirms the effectiveness of our clustering from the previous steps. Sometimes picking the right number of groups is tricky. The elbow plot can help us decide. This comment explains we are about to check the ideal number of groups. We make an empty list for storing the sum of squared errors. We try different cluster counts from 1 to 7. Each time, we fit the k-means model. We save how tight the clusters are after fitting. Now we draw a plot showing how each extra group improves or adds less improvement. The line will drop sharply, then flatten out. Look for the bend. That is usually the best number of clusters. Running the cell now. This elbow plot shows how inertia, a measure of cluster compactness, decreases as we increase the number of clusters from 1 to 7. Notice the point where the inertia reduction slows down, forming an elbow, which helps us choose the optimal number of clusters for segmenting customers. This step ensures that our subsequent cluster visualization is based on a well-chosen, meaningful number of groups. Step 7. Customer segment analysis. Can you describe what kind of customers are in each segment? Let us see the average features for each group. Running the cell now. A quick look at group averages gives us a sense of what makes each cluster special. We group by cluster and calculate average values for age, gender, income, and spending score. Running the cell now. The output shows the average characteristics of customers in each cluster, revealing key differences in age, income, and spending score. Notice that Cluster 0 has older customers with moderate income and spending, Cluster 1 consists of younger customers with high income but low spending, and Cluster 2 includes the youngest group with moderate income and the highest spending. This summary helps us understand the distinct profiles of each customer segment. YouTube call to action: if you are finding this useful, hit thumbs up and subscribe for more beginner data mining walkthroughs. Challenge exercise. Try these challenges. 1. Cluster with 4 different groups. What changes? 2. Find the average age for each new group. 3. Create a scatter plot using age instead of annual income. Are the clusters clear? Share your thoughts below. Running the cell now. Practice, tweak group numbers, try changing the cluster colors, or explore different columns. That is how you learn best. Recap what you learned. You loaded and inspected real customer data. Prepared it for analysis. Used k-means for clustering. Explored results with plots and group averages. Practice describing each segment. Great job! See you next time. Running the cell now. Want more data mining fun? Hit subscribe and turn on notifications for more videos. Let us keep learning together. Running the cell now.